Hey, welcome back to Tansy Academy. In this lesson, chapter 2, lesson 2, we'll be talking about software development lifecycle. Now we are going to get into a little bit technical. Lesson 1 was on software application. You have already used, you are being used, and you already used software applications on your mobiles, web apps, on your smart TVs. But this lesson is about software development lifecycle, little bit more technical that you might not be aware of. So let's see how we can define what a software development lifecycle is. Let's say that just like constructing a house, developing software happens step by step. Say in the previous lesson we have seen what an application is. You have a YouTube software application to watch videos, you have WhatsApp software application to communicate with people, and then you have many other applications. Let's say banking application for you to make banking transactions, right? But behind the scenes, what happens? How is the software application built? Same way, when you are trying to construct a house, there's a step by step, things happen, the tasks, different tasks are accomplished step by step. Same way software development, it's not like you do it in one shot. No, there are different steps, different methods applied, different frameworks applied when you develop a software. So when you try to construct a house, you actually plan, right? What do you want? Before building a house, you decide what kind of a house you need, the size, rooms, floors, style, exterior, interior, all those things that comes under planning. In the same way, in software, you planning means deciding what the app or software should do. Okay, this is one phase of constructing a house or a software. And this, after you plan, you move to the design phase. In case of when you're trying to construct a house, you have blueprints or the design of the rooms, like let's say dimensions of doors, windows, walls, and all that stuff. Architects creates blueprints before construction begins, right? In software, developers create a design or a model of how the software will look and work. Even in the software, there is a architecture phase of any given software application. There is architecture phase too. So you actually design to say, okay, this is what a software needs to do, but how are we going to accomplish it? And so this will be designed or architect at the design level. So after designing is done, then you go for building. The construction begins. So workers build the house based on the blueprint from the design. Same way, the software programmers write the code to build the app or system based on what was designed or architected in the designing phase. And then after you have planned, you have designed, the building is done, then you have to test to make sure it meets the specific requirements. Before moving in, you inspect the house for leaks, wiring, or broken things. Same way in software, testers check for errors to make sure it works correctly. Let's say that you have developed a banking application, you have logged in with your user ID and password. You have to test to say, okay, what happens if I give wrong password? Will I open some XYZ account? Will I see the transaction? Can I debit credit? No, it's not supposed to do that, right? So someone has to test the software to make sure it is meeting the required criteria. And then after it's tested, it's deployed. It's similar to when you move into a new house. Once the house is ready, you move in and start living. In software, the app is launched for people to use. We call it deployed to the production. And then after that, there is a maintenance phase. You repairs and updates. Over time, houses needs repairs and upgrades like painting, plumbing fixes. In software, developers fix bugs and update features to keep it running smoothly. So overview. So how do you sum up what we have just learned, what a software development lifecycle is, right? In a short, you can call it as SDLC. SDLC is a systematic process used by the software industry to design, develop, test, and deploy the software. It provides a structural approach to software development, ensuring that all necessary steps are followed from concept to deployment. Let's say that someone is trying to build a house. This used to happen before. They directly used to go for construction without spending money, or without hiring an architect, or without even having a plan to say how many rooms we want, and they used to directly go to building, right? So you can also do that in a software, but that's not the ideal situation or ideal scenario. So the entire software industry throughout the world, they came up and said that we need to define standards how a software is built. So that is what is part of the software development life cycle. What is the purpose and goal of to have something like that? The primary purpose of SDLC is to produce software that meets or exceeds customer expectations while being delivered on time and within budget. It also provides a framework for standard set of activities and delivery. So this is very important. SDLC provides a standard set of activities. Let's say you have built a house without a blueprint. After maybe you once you move in, maybe the door doesn't fit into the wall, or window doesn't fit, or window might not open. Even if you open the window, there might not be light on the other side. So things like this happen if you don't proper follow the proper standards, like printing a blueprint of your house, and then designing, planning, and then construction. So same things happen in software. If you don't plan properly, if you don't architect properly, after you spend $1 million or $100 million, when it goes to production, you might find an issue that cannot be fixed. Okay. Phases and iterations. While SDLC can be approached through various models such as waterfall, agile, and again I told you, right, there is a framework for a standard set of activities that needs to happen to produce a software. And again, this framework, there are different frameworks, and again, this is totally out of scope because this course is related to SQL training. You want to become a database developer, so we are trying to learn what a SQL is, what a database is, what a query is. So I'm not going to go into detail about all the frameworks. I'll just talk about top 2 frameworks that are most widely used in today's software industry. Quality assurance. By following a defined cycle, the SDLC ensures that the software is consistently produced with high quality, minimizing the risk of project overruns and ensuring functionality and security. So that means, to meet within time, delivering the software in time, on budget, and making sure the security is there, so that there won't someone else won't get into the software like banking and try to steal the information. So if you follow this framework, you will be protected. That's what it means. Let's take another example, right? Life cycle of wheat. Wheat is cultivated in the farm, and from there it goes to a processing plant, and after it's processed, wheat is transported to a processing plant where it is cleaned, sorted, and milled into flour. From here it goes to a warehouse. The milled wheat flour is then packaged and shipped to a warehouse for storage, awaiting distribution to various retailers. And from here it goes to a retail stores. So sold in retail. Wheat flour is delivered to retail stores where it is sold to consumers in various packaging size for home or commercial use. And from here it comes to our kitchen, store in kitchen. We purchase the wheat from retail and bring it to our kitchen, and then we cook it and we bring it on the table. So there are different steps involved for the wheat to come to the table in the form of a bread. So in the same way, there are steps for software for producing a software or developing a software. So that is part of the software development lifecycle, SDLC. There are 6-7 phases you could call. In the phase 1, you will plan, define project goals, resources, and establish timelines and milestones. In the 2, you will analyze, you will gather and define the specific requirements, what needs to happen in the software application, who will the users, what he will do, what the employees will do, and so on. And depending on the requirements, the software architects will design the software, and this design is passed on to the phase 4, where the software developers, people like you, will start coding according to the instructions in the design level. And after you are done with your coding, and again here there are different developers, front-end developer, back-end developer, and database developer. So you will be performing the database developer role here. Okay. And then after you are done developing the database programs, depending on the design instructions, it will be pushed to testing. So there will be different resources who will test what you have coded to make sure that it meets requirements. And then if everything goes well, it will be deployed into production, and then you'll have regular maintenance after it's deployed. You see, if there is any error in the testing phase, it will be sent back to coding part, and then you have to recode it, fix the bug, and then you again send it back to testing. So this is how the companies develop software application. So as I told you, I'll be talking only about 2 famous frameworks that are used as SDLC framework. So first one is waterfall development method, and the second one is agile. I think 90% of the companies today they are using agile to develop softwares, agile framework. So let's see what is the difference between agile and waterfall. uh, in a waterfall, what happens, we have seen this, right? Planning, analysis, design and all. So in a waterfall, they will analyze the requirements of the end-to-end software, right? Let's say banking application. In a banking application, you have loans processing, you have credit cards, you have savings account, you have checking account, right? And there is someone called collection team, and you have customer support. So all the requirements are collected end to end in this phase, and for these requirements, for these functionalities, for these different software modules, the design will happen. Okay, so after completing 100% of the requirement gathering, then only design will start. So this is the difference between waterfall and agile. And after the entire system is designed, then only coding or implementation development will start. After this is done, then this will be taken care. After this is done, it will be deployed. But in agile, it is not like that. Agile, you break down your software application into multiple pieces. How do you break? You break down such that a given if you say that, okay, I am not taking the whole banking application as a whole, let me first develop the loan processing, or let me develop the credit card issuance. So even within that loan processing, you will pick up the task such that it is finished in like one sprint. Generally a sprint is, it goes for 2 weeks. So if you say I have 10 people, 20 people, 100 people on my team, how much can they develop in a given 2 weeks time frame? It's not only development, all the people coming together. You'll be having designers, you'll be having developers, you'll be having testers, you'll have people to deploy, and all this together, how much piece of software can you push it to production that makes sense for the end user? So in agile, they break down the software, and they take up the tasks from the bigger pool. So the amount of tasks that they can finish in 2 weeks as a sprint. In some companies, they can also have sprint for 3 or 4 weeks, but mostly it's 2 weeks, or it can be also 1 week. So within the sprint, in a week, they will plan, design, build, test, review a small piece of requirement, and they push. And then in the next sprint, they will pick other requirements that are not coded in sprint 1. So in this way, the whole software is developed in different sprints. It might even go to 100 sprints. So what happens in a sprint? In a waterfall, you first analyze the whole software, but in the agile, you do not analyze all the requirements. You just say, okay, how much you can do in a week or two, that's what you take. You analyze, design, build, test, and push it to production. So this is what most of the companies are following these days. Okay, so let's move on to next lesson.